Hello and welcome to another video. So we're doing a 928 Scorekeeper today. You're given a positive integer n, and this indicates that you have n teams numbered from 1 to n that you're going to play a series of matches with. You're also given a 2D array where the 2D array contains a set of tuples which have different teams, and the winning team has a positive number whereas the losing team has a negative number. And our goal is to figure out whether or not the a certain team has lost yet, and we want to return that at the very end. Now, so we're given a couple of constraints here where the winner, well, there always has to be a different number for between A and B over here. And we only want to include distinct cases. Well, we want to return the number of teams that have not lost any match. Okay, this makes sense. So an idea of what I was thinking is, because we only care about the number of winners, right? The ones that have never lost one in the past. What we could do is we could have a set which contains all of the winners at a given certain point, right? So we can have winners over here, and then we'll be adding the numbers as we keep iterating through all of the different possible teams, right? So we have 1, it's positive, so it's winning, so we add that. You can't add 2 because it's a negative number, right? And then we have 1 again, still working, and because it's a winning one, 1 wins again, 1 wins again. We have 1 at the very end, so at the very end we can return the length of the winner's set. Now, same thing again with this case. Let's say we have 1 is winning, so we add that. 3 is winning, so we add 3 to the set as well. And then we have 1 is winning, and then 1 loses, so we have to remove that from the set. But at the same time, 5 wins, so 5 wins over here, and then we pretty much get a win over here. Because since these two numbers are in the set, we want to return 2 as our final result. So I'm kind of getting an idea of the problem right now. So I'll go ahead and begin coding up the solution for it. What we could do is we could have the winner set, we initialize it, and then first things first, we want to iterate through all of the elements in the 2D array. So for, for set, So for, let's say for game in matches, or I guess for a match in matches, we know that the winner is going to be the positive one. So we want to do if match 0 is greater than 0, right? Then we know the first number is the winner. Likewise, if match the other match is the winner, then we want to have that added to the set. So we'll do that. So winners dot add to the set match 0, and same thing, winners dot add match 1, because we know guaranteed one of them is going to win, right? So it can't equal the same thing, and there has to be a winner, right? Looks like there's an any constraint which says that. Nice, yeah. Oh, and we also want to be adding the absolute value of it, just because that's the actual team value itself. So once we have that, for every single match in matches, we want to add that, and simultaneously, we want to check to see if winners.add, if we want to check to see if the number has lost, right? So if the number is lost, if match 1 is in winners, then we want to remove it. We want to remove from the winners dot remove from the set match the absolute value of match 1. Absolute value of match 1. Likewise, same thing if the other one happens for the match 1. If it wins, then we want to check to see if match 0 isn't there, right? So we'll do if match 0 is in winners then we want to remove it. So winners.remove absolute value of match 0. Now at the very end of this, what we want to do is we want to return the length of the set over here. So we want to return length of winners. At least I think that's what the proper syntax is. Let's see. Check length of set Python. Yeah, blend. Okay. Okay. So just looking at this again one more time. Winners equals set for every single match. We want to check to see whether or not it's greater. If it is, then we add that to the winners, and then if the match 1 is in the winners, we want to remove it because it's obviously a negative number, and we just do the flip of that for the other one. So match 1 and then match 0, remove the absolute values of match 0, and after that we return the final length. So let's go ahead and run the code, see if it works for our test. Okay, incorrect answer. In line 24, it's not okay. Whoops, it says over here type int is not iterable. Let's see. Let's see where an area where it's iterable. Oh, I see. Oh, looks like it's flipped. Looks like the person who created this problem made it flipped. Yeah, interesting. Okay, well, we have an incorrect answer over here. Failed to pass all test cases. So we can go ahead and print out, check to make sure whether or not what's going on here. So we have matches, and then matches, and then we have n. We have n to be n, and then so once again, and then we'll return the length of the winners. So we'll print out the winner set at the very end, and then we'll see what the result is. Getting another error over here. Oh, yeah, it's got to make this a capital, actually. There we go. Println winners. Okay, that's weird. We have... Oh, okay, I see. After all the matches, you return the number of teams that have not lost any match. So, interesting thing about this, I didn't realize this, is that they gave us the initial number of teams that are going to play a series of matches. So we have to be subtracting from that at the very end. So we need to be keeping track of all the ones that lost, right? Okay, well, in that case, we can have it so the winners, we can make the winners the losers, actually, if we think about this. So if it's a negative number, then we add it to the set. So if it appears as a negative number. So if it is less than 0, then we add it. If the match 0 is less than 0, then we add it to the losers. And then if it wins, then we add it. Okay. Return the number of... Okay, so we want to return the number of teams that have not lost any match. Okay. Return the number of teams that have not lost anything. Because we know in this case that it's going to be equal to to 5, right? Where we have that. what we want to do is we want to figure out what the losers are. So let's think this through first. So losers is going to be equal to the length of the winners to n minus the length of the winners, right? Because those are the losers. Yeah, so to find the winners, winners has to be equal to the minus losers, which in this case would be 0. Yeah, because the losers initially is n minus winners, because we have 5 number players and 5 winners players who all of them won, right? So let's actually just run this really quickly. Let's think this through. Winners. Okay. The winners indicated by a positive team number. This is where I was, checking. It's not possible for team to have played any matches. Let's think about this. The winners. For example, we have for matches, if it's less than 0, we want to add that as a loser. So we do losers.add absolute match 0. Match 1 in losers, if it's 1, well, it doesn't really matter either way, so we'll comment this out. Otherwise, one add losers. So losers.add absolute value of match equals 1, and then do this. So add match 1. And then you want to return the length of the losers n minus the length of the losers. Nice, so it works for all of the different cases. Okay, that makes sense. Okay, so my problem with what I was doing is that I misunderstood the actual problem itself. I mistakenly didn't look at the number of parameters that this problem had, because I initially assumed that it had that the only relevant one was the number of matches, and we would figure out how many winners and losers was based off of that. But I failed to see the n number, which is the actual number of teams that you were winning or losing. So that's where I made the mistake, and I'm going to fix that for the next go around with another problem. In terms of time and space complexity, the time complexity of this is O of n, because you're only really iterating through O of n represents the number of matches, because you're iterating through everything only once. Space complexity would be O of n also, where because at the worst case, everything could be stored inside the loser set array. So yeah, it would also be O of n as well for the space. I'll go ahead and quickly write a solution explanation here. Okay. I think that's good. Good to set up with keep track of the number of losers and it waits to every match and into the set the loser of the match. Due to the properties of the set, no duplicate losers can be added, so by the time the iteration is finished, all the teams that have lost are there. From then on, it's a matter of subtracting from the number of teams to arrive to the final solutions. Time is event space. Go ahead, run this one more time. Make sure it's good. And then we'll go ahead and submit this. Hopefully it saves. Nice. Okay, well, thank you guys for watching.